The universe is vast, it's filled with mysteries. Understanding it has captivated humanity for millennia. We yearn to know what makes the cosmos tick. How do its intricate parts come together? Today, we embark on a journey. We'll explore a new theory, one that could unravel the universe's secrets. This theory is bold, it's elegant, and it all starts with motion. Imagine the universe not as a static picture but as a dynamic dance. Everything is in motion. This motion is fundamental. It's the basis of existence itself. From the smallest particles to the largest galaxies, everything is moving, swirling, vibrating. This is the core of our unified field theory, a theory that sees motion as the driving force behind everything we observe in the cosmos. Let's dive in and explore the fascinating implications of this profound idea. To understand this theory, we need to introduce a new concept, the Kiron. Imagine Kirons as a 2 to 3% larger than Planck's scale, one-dimensional point of free space. They are the most fundamental building blocks of reality. Think of them as the pixels that make up the grand cosmic screen. Kirons are not static, they are in constant motion, vibrating, oscillating, and interacting with each other. This constant motion of Kirons is what gives rise to the fabric of space and therefore time itself. They are the threads from which the tapestry of the cosmos is woven. But how do these one-dimensional entities create a three-dimensional world? How do we go from a one-dimensional point-like environment to a three-dimensional universe with depth and volume? The answer lies in the chirality of the Kiron, which affects how they interact. Picture a vast ocean of Kirons all vibrating and moving randomly. Now imagine patterns beginning to emerge from the chaos. Due to the asymmetry of Kirons themselves, they begin to orientate and align in specific configurations, facilitating the chirality and/or direction of all temporal phenomena. And while Kirons are one-dimensional points, when they align in one direction they create a single dimension, a line. When they align in two perpendicular directions, we get two dimensions or a plane. Finally, when Kirons align in three perpendicular directions, we get the familiar three dimensions of space that we experience every day. This alignment of Kirons isn't static, it's dynamic and ever-changing. The fabric of space and time is constantly changing and expanding as Kirons shift and realign in response to various forces and energies it encounters. This dynamic interplay of Kirons gives rise to our dynamic and ever-evolving universe. Now let's talk about time. In this framework, time is a completely separate entity from space. Instead, time emerges from the very motion of space itself, which is composed of the Kiron field. Think of it this way, imagine a single Kiron moving through the quantum sea of other Kirons. The number of interactions it undergoes with other Kirons as it moves can be thought of as a measure of time. This concept of time is inherently linked to motion. Section 5, Space, Time and Motion. So we have space woven from the fabric of Kirons, and we have the motion of those Kirons, which facilitates the emergent effect of time. Another way to think about this concept is to imagine the liquefaction of the Kiron field, where the motion of the Kiron field produces the emergent effect all objects experience as time, which quantum uncertainty continues to demonstrate, ultimately giving rise to the second law of thermodynamics, highlighting the inherently interconnected and interdependent nature of this framework, influencing and shaping the cosmos. It suggests that we cannot fully understand any one aspect of the universe without understanding the others. Space, time, and motion are completely separate aspects of reality, but they are inextricably linked, as all forces are just different manifestations of the same underlying unifying force of motion. Section 6, Temporal Absence. But what about space without time? Can space even exist without time? According to this theory, the answer is yes. But it's a strange and unfamiliar kind of space. Imagine a region of space where all Kirons are perfectly still, frozen in place. In this hypothetical scenario, there could be no motion, and therefore, no time. This region would exist outside the flow of time as we know it. This concept of timeless space might seem purely theoretical, but it could have profound implications for our understanding of the universe, especially when we consider extreme cosmic phenomena like black holes. Section 7, Cosmic Maelstroms, Black Holes, and the Fabric of Reality. Black holes are among the most extreme objects in the universe, and are regions of space possessing extreme Kiron density gradients. distorting time and generating a gravitational force so powerful, it prevents the escape of light itself. But how do black holes fit into the theory of Chirons in motion? According to this theory, black holes represent areas of extreme gravitational fields, also known as the Kiron density or spatial density gradients, or SDG and KDG, respectively. So imagine a spatial density gradient so extreme, it can even separate the constituent components of an atom. This extreme gravitational field compresses the baryonic matter to a 100% density. At the center of mass of the singularity, Kiron density reaches 0%, meaning it has rid itself of all empty space. And it is this environment that leads to the function of both dark matter and dark energy. And any object or region containing 100% baryonic density should be incapable of undergoing motion, or even experience the function of temperature. Therefore, time itself should cease to exist in a singularity. But it may even behave in ways that we cannot predict or even begin to imagine. Section 8. The function of gravity and emergent force. For centuries, gravity has been one of the most puzzling forces in the universe. But in this framework, gravity is not a fundamental force. Instead, it emerges from the behavior of Kirons and their interaction with matter. Remember how we talked about Kiron density varying throughout space? These variations in Kiron density create what we perceive as gravitational fields. Imagine a dense region of Kirons, like the area around a massive object. This region will have a stronger gravitational effect than a less dense region. Objects, including light, moving through regions of changing Kiron density gradients. Experience this as a gravitational field, because the Kiron density field gradient is how baryonic matter interacts with space and time, and is what we experience as a gravitational field. Section 9. Atoms in the cosmic ocean, navigating density gradients. You can imagine atoms as tiny gyroscopes that are precessing their way through the cosmic ocean of Kirons. When a gyroscope enters a region of changing spatial density gradient, i.e. a gravitational field, the atoms and/or gyroscopes encounter an asymmetrical time dilation of the gyroscopic precession, which produces an asymmetrical resistance on the side of the gyroscope facing the center of mass. And because a changing spatial density gradient necessitates a changing temporal density gradient, or TDG, meaning time passes by slightly slower on the side facing the center of mass, which facilitates the center of mass as the path of least resistance, which produces the force we know as gravity. But it is the displacement of the Kiron field, in the presence of baryonic matter, that generate the gravitational field, or Kiron field density gradient, which in this framework can be thought of as a type of gravitational buoyancy. And the greater the spatial density gradient, the greater resulting force of gravitational buoyancy. This concept of gravity as an emergent effect through the Kiron field density gradients, as it interacts with the gyroscopic functionality of atoms, provides a new way of thinking about this fundamental force of motion. It ties gravity directly to the fabric of space and time itself, further unifying our understanding of the cosmos. Section 10. Implications and reflections, unifying the cosmos. The unified field theory presented here, based on the concept of Kirons and the primacy of motion, offers a compelling and elegant explanation for the workings of the universe. It unifies space, time, gravity, and energy itself, the motion of baryons, into a single coherent framework. This theory has profound implications. It suggests that everything in the universe is interconnected through the function of motion. It challenges us to rethink our place in the cosmos, not as separate from the universe, but as integral parts of its grand design. By viewing the universe through the lens of motion, especially that of Kirons, we gain a deeper appreciation for its beauty, complexity, and the interconnectedness of G-theory. It's a humbling and awe-inspiring perspective that highlights the vastness of what we still don't know. Section 11. Invitation to explore the never-ending quest. The quest to understand the universe is a journey without end. Each new discovery leads to more questions, urging us to delve deeper into the mysteries of the cosmos. The unified field theory presented here is just one step on this endless journey. It's a stepping stone, a new perspective that encourages us to continue exploring, questioning, and pushing the boundaries of our understanding. So let's keep looking up at the stars, keep asking questions, and keep searching for answers. The universe is full of wonders waiting to be discovered. And who knows what other secrets we might unlock as we continue to explore the cosmic dance of Kirons and the profound implications of a universe driven by motion.